In this video, I'm going to explain another template, and this one is for factorials. So say I have n factorial, so that's 1, 1, 2, 6, 24, and so on. Say I were to shift this and transform this. Let's say I multiply every term by 2 and add 1. Then I'll get this. So if we were given this first sequence here, it would be pretty easy. But when we're given this, when we are multiplying it by our n factorial by 2 and then adding 1, it's not so clear that we would get this uh, from this formula. And in this video, this template just shows you a way to test if it is indeed a transform version of a factorial. And here's a derivation for these formulas that I've shown. So the general form for transformations for n factorial can be written as this. And now, as always, I'm going to say that the terms of this are a0, a1, a2, a3, and so on. And then I'm going to use systems of equations because my goal is to write a, h, and k in terms of these constants. So this would be yeah, I'm just writing out the terms. And this should be all we need. So now I'm going to just subtract a1 from a0 and let's see what we get. So if we do a1 minus a0, well, the k's are going to cancel out, but then what is this? What is a times 1 plus h factorial minus a times h factorial? So we can just factor out the a from that, and let's just look at what is 1 plus h factorial minus h factorial. Well, we can write this out. This is 1 plus h times h factorial minus h factorial. We can factor out an h factorial, and we do that, we get 1 plus h minus 1, and this is just h times h factorial. So this kind of tells us what a1 minus a0 would be. So a1 minus a0 is going to be a times h factorial, uh, and this is a1 minus a0. So uh, now what we'll do is we're going to repeat this process for a2 and a1, and since we got we got h times h factorial from this right here, if we just do 2 plus h factorial minus 1 plus h factorial, it's just going to be the same thing, but just add 1 to this h. So this will look like okay. So this is a2 minus a1, and now we can actually use what we have here and rewrite this. And this will be a times h plus 1 squared times h factorial. I'm just rewriting what we have here. Because now that we have it as h factorial, we can rewrite this h factorial here. So this h factorial is equal to a1 minus a0 over a times h. So if it's a1 minus a0 over a times h, then we have, so now here we have a1 minus a0 over a times h. So this is a2 minus a1. And then from here, we can see that the a's cancel. And we can rewrite this a little bit. And when we rewrite this, we're going to see that we have h plus 1 squared times a1 minus a0. And I'm just going to get rid of the h, so there's no fractions. And then this is equal to h times a2 minus a1. And if we see what we have up here, it matches. H plus 1 squared times a1 minus a0 is equal to h times a2 minus a1. And this equation is really helpful because we just have one variable and only constants. So we can solve for h. So using this, we can find h, and then from a previous equation, we can also find what a is. And this is all summarized in this table here. And let's look at an example of how this can be used. So let's go to that first example that we had before, where we had n factorial, which was 1, 1, 2, 6, 24, and so on. And then we multiplied each term by 2 and added 1. Okay? So if we multiply each term by 2 and add 1, we get, right? Yeah. And say that we're given the sequence, and we test it against this template. And another reason we would choose to test it against this template is because if we look at the ratios between each term, um, this would be 241. So the ratios between each term, it goes times 1, times something a little bit over 1, right? 5 over 3 times 13 over 5. And these ratios are constantly increasing. Because of that, we can kind of infer that it's going to be related to this factorial template in some way. So that's a reason we would test it against this template. So let's do that. And let's use our final formula here onto here. This is what we just derived. And now we plug in the numbers. And if we do that, here we're going to get a1 minus a0. So that's 0. So we have 0 is equal to h times a2 minus a1. Now, here's the interesting thing here. Oh, so the interesting thing here is that we already know that a2 minus a1 is not 2, is not 0, right? Because 5 minus 3 is 2. So because a2 minus a1 is not 0, it means h has to be 0. So if we look at our formula, we now know that it's going to look like a times n factorial plus k because h is 0. So now, if we look at our other formulas, we know that we can solve for k because k is a0 minus a times h factorial. And h is 0, so we have k is, and then a0, it would be 3, so 3 minus and this is just A. And now, how do we find A? The easiest way to find A is to just use systems of equations with these first two. So we have, on 1, we have A times H factorial plus K is A0. And the other is going to be A times 1 plus H factorial plus K is A1. And we know that H equals 0, so that means that this is just A plus K is A0, which is 3, and this is 0 plus 1, so 1 factorial, so 1. So we have A plus K is equal to 3. And we can see here that this systems of equation was not very helpful because we just got two things which are exactly the same. But that's fine because we can also use the next equation we have here, which is A times 2 plus H factorial plus K is A2. And then H is 0, so we have 2A plus K is equal to A2, and A2 is 5. And we have A plus K is equal to 3. So we subtract these two, we're going to get A is equal to 2. So now that we know A equals 2, we can go back to this equation, and it means that K is 1. So we know that K is 1, H is 0, and A is 2. So now we have our answer because we know all our variables. So the answer should be, and this is exactly what we had from the beginning. So we know this is the right answer. So yeah, this is the factorial template, and I think it's very useful when you're dealing with something which has increasing ratios between the terms. So yeah, thank you for watching.